Today I'm going to be talking about areas of regular polygons. This is day 2 of chapter 11, section 3. So our first problem asks to find the perimeter and the area of the regular polygon. So we're going to find the area first. Okay, and to find the area of a regular polygon, that's going to be our area equals 1/2 ANS. So I always like to write down my A, my N, and my S. That helps me organize to see what I have and what I'm looking for. We don't have the apothem. We can draw it right there. We don't have the apothem. We're going to have to find it later. But we do have the number of sides, which is 5. And we do have the side length, which is 10. So now let's solve for the apothem. If we draw an apothem, this does make a right angle, and if my side length is 10, then half of that is 5. So we can use this right triangle to solve for our apothem. And we can use our Pythagorean theorem to solve for A. So we can do A squared plus B squared equals, let's do this, A squared plus 5 squared equals 8 squared. Okay, because you know the Pythagorean theorem. So let's simplify. We have A squared plus 25 equals 64. Subtract. We get A squared equals 39. Don't forget to square root. And the square root of 39 is about 6.3. So we can plug that in. We have all three pieces. So we can go A equals 1/2 times 6.3 times 5 times 10. So we can plug this into the calculator. We can say 0.5 times 6.3 times 5 times 10 is equal to about 157.5. Our perimeter, we always do number of sides times side length, which is 5 times 10, which gives us 50 for the perimeter. Okay, and now we've got our area of our regular polygon. Let's try another example. We're going to write down our formula. A equals 1/2 ANS. Write down my A, my N, and my S. This time I do have my apothem, which is 5.5. My number of sides is 7. I don't have my side length though. So we need to look for this side length right here. It goes all the way across. Now if I notice, my apothem and my radius form a right triangle. And I can use Pythagorean theorem to solve for x. Now x is half the side of half of the side. So if we find x, all we have to do is double it and we find our side length. So let's try that. 5.5 squared plus x squared equals 7 squared. 30.25 plus x squared equals 49. We want to subtract. X squared equals 18.75, and we're going to square root both sides. Let's see what we get. About 4.3. Now this is not our side length. That is just half of it. So to get our side length, we have to remember to multiply by 2 to get 8.6. We only do this when we're finding the side length. We don't do it for the apothem. We just do it for the side length because x is half. Okay? So now we can put this into our calculator. We have area equals 1/2 of 5.5 times 7 times 8.6. And we get roughly 165.6. Perimeter is 7 times 8.6, which is going to be about 60.2. So that is our area and our perimeter. Let's do another example. We have area equals 1/2 ANS, A, N, and S. We have the apothem, which is 7. Our number of sides, which is 8. We do not have the side length. So we need to find that side length. So to find the side length, we have to find the base of this right triangle, which is going to be x. Now, we don't have any other information within this triangle, but we can find something. We can find our central angle of our regular polygon, which is 360 divided by the number of sides. So we do 360 divided by 8, which is 45 degrees. Now, if we remember, our central angle goes from radius to radius. So 45 is that whole entire thing. But what we want is half of that, because that piece of that triangle is half of that central angle. So we're always going to divide by 2, and we're going to get 22.5 for this angle right up here. Now that we have this angle and we have a side length of that triangle, we can use trig to solve for x, which we write down our SOHCAHTOA. To figure out which one we're going to use, let's label our triangle. Opposite of 22.5 is our x. 7 is our adjacent. What uses O and A? Tangent. So we're going to write down the tangent of 22.5 is equal to our opposite x over our adjacent 7. So we're going back to our trig, remembering how to write our trig equations. To solve for this, we multiply by 7 on both sides. So 7 times the tangent of 22.5 is equal to x. We have to put that into our calculators. Make sure your calculator is in degree mode, or else you're going to get the wrong answers. So we have 7 times the tangent of 22.5, which gives us roughly about 2.9. Now remember, we need to find the side length. And to find the side length, we have to multiply that x value by 2. So that's going to be 5.8. So our side length for this one is 5.8. We can now plug this into our formula. 7 times 8 times 5.8. So 0.5 times 7 times 8 times 5.8. It's going to be about 162.4. Our perimeter is 8 times 5.8, which is 46.4. We've now got our area and perimeter. Okay? Our next one is we're going to find the area and the perimeter again. So we have to write down area equals 1/2 ANS. Okay, we don't have the apothem this time. We do have the number of sides, and we don't have the side length. So what we're going to have to do for this one is we have to solve for 2 variables. So let's solve for the apothem first. We can draw that with a right angle. Since we only have one number, we have to solve for our central angle, which is 360 divided by the number of sides, which gives us 72 degrees. And then don't forget that 72 degrees has to be divided by 2 to get that top part of that triangle. Now that we have our 36 degrees, we can write down our SOHCAHTOA. And let's label this triangle. 17 is our hypotenuse. A is our adjacent. A and H is cosine. So we can write our formula for cosine. So we have the cosine of 36 is equal to adjacent over hypotenuse. Okay, so now we're solving for the apothem. We multiply by 17 on both sides. 17 times the cosine of 36 equals A. Let's plug this into our calculators. And we get about 13.8 for our apothem. Okay, now we need to solve for our side length. And to solve for our side length, we have to figure out the base of that right triangle, which we're going to use x. Okay, so the x is our opposite. Our 17 is our hypotenuse. So O and H is sine. Okay, so we're going to use the sine of 36 equals our opposite over our hypotenuse. We can now multiply by 17 on both sides. 17 times the sine of 36 is equal to x. Let's put that into our calculators. And we get about rounded to a 10. Now remember, this is our value of x, but to get our side length, we have to multiply by 2. Don't forget to do that, only for side length. Now we have all three pieces. We can plug this into our formula. So we have 0.5 times 13.8 times 5 times 20, and we get about 690. And 100 is our perimeter because it's 5 times 20. All right, I have one more example. Let's look at that one. Okay, we have area equals 1/2 ANS. We don't have the apothem. We do have the number of sides, which is 5, and we do have the side length, which is 15. Okay, so we're going to look for our apothem for this one. Let's draw that in. Draw a radius. Okay, so we have the apothem. We also have the side length, and if we divide 15 by 2, which is 7.5, that gives us the base of that triangle. Now all we need to do is find our central angle. Which is 360 divided by the number of sides. And don't forget, we have to divide that central angle by 2 to get that top part of the triangle. Okay, we can now write down our SOHCAHTOA. And we can label our picture, our triangle. Opposite of 36 is 7.5. A is our adjacent. OA is our tangent. So we have the tangent of 36 equals our opposite 7.5 over our adjacent. We're going to multiply by A on both sides. We now have A times the tangent of 36 equals 7.5. Divide by the tangent of 36. And our apothem is going to be, let's put that into our calculators, tangent of 36, about 10.3. That one was much easier compared to the last one. So now we can plug this in. Okay, let's put it into our calculator. 0.5 times 10.3 times 5 times 15, and we get about 386.3, and our perimeter is 5 times 15, which is about 75. So those are all of our examples, the different instances of finding area of a regular polygon.